Everyone, today we are going to study about eyepiece. So we'll discuss first what is eyepiece and what is the function of an eyepiece. So the first is what is eyepiece. Eyepiece. It is also named as ocular lens, ocular lens, or simply ocular. Alright. So what is eyepiece? So eyepiece can be defined. It is a type of. We'll just write is a type of lens that is used, or we can say that is attached to a variety of optical devices, attached to a variety of optical optical devices such as it can be telescope and a microscope. Right. So what is its use? Eyepiece, use of eyepiece. So use of eyepiece, it's simply what magnifies it. This is magnifies the primary image, primary image produced by objective, objective. All right. So simply eyepiece is nothing. It is an optical device, or we can say it is a type of a lens. It is a type of a lens that is attached to a variety of optical instruments such as telescope, microscope. So use an eyepiece is which magnifies the primary image which is produced by the objective lens. All right. So we will just start its intro. If you remember microscope, microscope and telescope, which we already discussed in our classrooms, these both are suffer from what microscope and telescope, these both are suffers from various defects, various optical defects. First one is, as we already know, first is chromatic aberration. Chromatic aberration of the lens. Right. Second is your spherical aberration. So if you memorize what microscope and a telescope, these both are suffer from some in its optical defects, which is chromatic aberration of lens or spherical aberration. If we recall ourselves, so the chromatic aberration, this chromatic aberration is reduced by, how we reduce this, or how we remove this? We remove this. We already discussed in our third unit in aberration. Just I'm recalling it. Chromatic aberration is removed by which method? By achromatic combination. Achromatic combination of what? Combination of lenses. Whereas the spherical aberration is removed by which method? Just we use the more spherical surface of lens. Surface, which type of surface? From where the incoming parallel rays are coming, or we can say is towards the incoming parallel rays. All right. So what we have discussed, what is eyepiece? Eyepiece have a second name, which is an ocular lens. We can say it is a type of lens that is attached to a variety of optical devices such as telescope and microscope. Use of eyepieces just magnifies the primary image which is produced by object lens. We will discuss this after with a ray diagram. Right. So if you memorize, microscope and a telescope suffers from the variety of defects, which what are those defects? First is chromatic aberration, which is removed by how we remove the chromatic aberration from any lens. So we use an achromatic combination of lens. All right. And the second one is spherical aberration. This is used. This defect is removed by we use a more spherical surface of lens where the incoming parallel rays are coming. All right. So this we already discussed. If we see the I cannot hold, or we can say that we cannot I cannot held so close to the eyepiece because I cannot held so close to the eyepiece. This is eyepiece, okay? Eyepiece, because the rays from the extremities of the image of the image are refracted by, or we can say refracted through the peripheral portion, refracted through the peripheral portion of the eyepiece. Good. And we can say the best portion of eye is eye ring. Suppose this is our eye, this portion. All right, this black portion. Just to this gives this black portion, or this ring gives the best image quality. All right. To avoid this difficulty, we use field lens. Okay, so this is some theory of eyepiece. Now just look at here. Field lens, if you take an example, you will understand here properly. So this is our principal axis. Suppose this is some objective lens. This is our objective, say L1. If we place an eye lens, some eye lens, all right, say L3. Okay, so the incoming rays, suppose the incoming rays just increase this here. Alright, just let me erase this one. Alright, this one too. Let me just let me erase this. Alright, so suppose the angle makes by the objective lens is alpha. Alright, just increase this principal axis, just increase this principal axis, so it will make somewhere here. So this point, say this point is A, or we can say is this A where the eye is be held. Which portion of A is which portion of eye is A is a center of exit. Center of exit pupil. Alright, this A is the center of exit of pupil of this eye. Alright, suppose this eye is located somewhere here. So the image form, so this is the angle beta. Say this is an image angle, so say this is a beta angle. If we place a lens L2 somehow here, alright, somewhere here, so the light ray parallel coming to, so the light coming it's difficult to draw here. Suppose say this comes from here, this must be a straight line. Just to understand this one, see the angle increases by alpha dash. This angle is larger than alpha 1, right? And suppose match this line here, this makes the angle beta dash here. At some point, say this is B point, say this is B point, and this is beta dash. So from here, as we use the lens L2, which is a field lens, this L2 is, this one is your eye lens L3, and L2 is your field lens. So as we just place the L2 in between objective lens, eye lens, so the alpha is being changed into alpha dash, or we can say that alpha dash is greater than alpha. Here the magnification of the objective lens through the objective lens, and here beta dash is greater than beta. So this combination of the field lens L2 and the eye lens, which one? This one, eye lens L3 forms the eyepiece, eyepiece, or we can say the ocular, So the combination of what? If we simply say what is an eyepiece? What is an eyepiece? Eyepiece is nothing but the combination of field lens plus which? Eye lens. Right? Say this is L2, say this is L3, okay, or say ocular. So the eyepiece is nothing but combination of field lens and eye lens, say L2 and L3. What it actually do? This is this brings what? Alpha to alpha dash. That means alpha dash is greater than alpha. It magnifies is the primary image. Magnifies is the primary image by objective lens. By objective lens. Alright. So in the beginning we had already discussed what use of eyepieces. The magnifies is the primary image produced by the objective lens. So we know now how the eyepieces work to do what magnifies is the primary image by the objective lens. It does nothing but it just increase the alpha angle. Alpha angle which is alpha dash is greater than alpha. So this is simply what the magnification. Okay. In general, if we write in general, function of field lens. Function of field lens. Function of field lens is first it increases the angular object field. As we know, alpha dash is greater than alpha. Second portion is it brings the center of the exit pupil nearer the eye lens. Or we can just nearer the eye lens and increase the angular image field. Increase the angular image field. First we know it increases the angular object field. That means alpha dash is greater than alpha for the first one. For the second one, it says it brings the center of the exit pupil nearer to the lens eye. As we see on the ray diagram, our point A was the center of the exit of pupil. It is now shifted when we place the field lens. It is shifted to this point, which is nearer to the eye lens. So the same thing we had written here. It brings the center of the exit pupil to nearer to the eye lens and increases the angular image field. That means beta dash is greater than beta. Okay. Third and the most important thing, function of field lens is it helps to minimize spherical aberration and chromatic aberration. Good. So this is the basic information about what eyepiece. So from the starting, eyepiece or ocular lens, it is a type of a lens that attaches to a variety of optical devices such as telescope and microscope. And a use of eyepiece which magnifies the primary image to produced by the objective lens. Okay. If you remember, microscope and telescope suffers from the optical defects which are chromatic aberration and spherical aberration. Chromatic aberration is removed by how? Chromatic combination of lens, and spherical aberration is removed by we make the lenses more spherical towards the parallel rays, incoming parallel rays. If we see, eye cannot held so close to the eyepiece from the ray which are coming from. So the image reflected through the perimeter portion of the eyepiece. So the best portion for an eye is the eye ring. Eye ring is this center portion, this one. this center, this black portion, or it can be brown according to the human body. So this center, this eye rings gives the we can say is the best quality image of an object. To avoid this difficulty, we use the field lens. Now, if you see that ray diagram, if we see the ray diagram, and we have an objective lens, and incoming rays comes to the eye lens, makes an angle alpha, this green one, and at a center A, at a point A, the center of exit pupil is here. If we memorize, we can say, if we locate an eye here, so here is the center of an exit pupil. All right. So which makes an angle beta. Now we place a field lens L2. We place a field lens L2. So the incoming rays makes an angle alpha dash, which is greater than alpha 1. Sorry, which is greater than alpha. Now the field lens makes the light rays goes to the eye lens, and which again by converse it goes to the point B. Now the point A is shifted to the point B. That means it makes a larger angle than the starting one. So the beta dash is greater than beta. So now we had written some conclusion, or we can say that the combination, or finally we say the combination of what? Field lens, the combination of field lens and eye lens. This is, suppose this is field lens and this is eye lens, makes an angle, together we say, or collectively we say this is an eyepiece, this is an eyepiece. Okay, so same here we written. If we write the function of field length, so simply it increases the angular field object. That means alpha dash is greater than alpha, where for the second point it brings the center of the exit pupil nearer to the eye lens, as we are seeing that point from it is shifted to point A to point B, which is here our eye lens. Now B is more closer to the eye lens. So point second says that it brings the center of the exit pupil nearer the eye lens and increases the angular image field. And increases the angular field mean, that means suppose this is beta dash and this is beta, so the beta dash must be greater than beta. So we have written this one. And third one, it minimizes the spherical aberration on a chromatic aberration. So in our upcoming lecture we will discuss the use of eyepiece, such as, or we can different types of eyepiece. We will study the different types of eyepiece, such as Eugen eyepiece, Ramsden, and again also known as a negative eyepiece. It is Huygens eyepiece is also named as negative eyepiece. And we will see the use of Huygens and Ramsden eyepiece, and collectively we will see the difference between both of them. Okay, so this we are going to study in our upcoming lectures. So please go through this video, and I think it will be helpful for you. Thank you.